Okay, good morning. This is the video for pre-calculus periods 1 and 7 for Tuesday, March 24th. It was nice talking to everybody online and seeing everybody. Hope you're all doing okay. We are doing solving quadratic trig equations today. Okay, so we're going to do a bunch. We're going to do like 5 of them, and then I'm going to give you a homework which has around 5 problems as well. So number 1, here what we're going to do, instead of working with cosine squareds, we're going to work with x's. So let x equal cosine of theta. So now I basically have x squared equals x. Then what I'm going to do is I'm going to subtract x from both sides and get x squared minus x equals 0, which is the same thing as x times x minus 1 equals 0. I took out a GCF. Now, so x equals 0, x minus 1 equals 0, add 1 to both sides, and I get x equals 1. So you should have printed out the handout off my website, the blank handout, and be doing everything on this. Now I have x equals this, 0 and 1, but x is cosine theta. So what I really have is cosine theta equals 0 and cosine theta equals 1. Now, I'm going to go back to our unit circle that we go back to over and over and over again. 1, 0, 0, 1, negative 1, 0, 0, negative 1, and that's 0, 90, 180, 270, and 360. So, and it goes cosine theta, sine theta. That never changes, okay? So the question is, when is cosine 0? Cosine's the one on the left. So at 90 and at 270, 90 degrees and 270 degrees, right? I don't like the way that 90 looks. I'm going to make it look better. 90 and 270. And then, where is cosine theta equal to 1? Well, just over here, which is at 0 and 360. And the reason why I'm including 360 and 0 is because it says 0 is less than or equal to theta is less than or equal to 360, so it's including it. Sometimes they don't. It might say less than, then I wouldn't include it. So 0 and 360 degrees, 0 degrees and 360 degrees. So these are called quadratic, by the way, because they have the squared. That's why they're called quadratic trig equations. Now, the final answer to our question, I list them in order from least to greatest. 0 degrees, 90 degrees, 270 degrees, and 360 degrees. And that was number 1. Hopefully you found that to be not that bad. Okay. Now we're going to do number 2. And again, with the video, you can pause it and rewind it. So that's a nice option. If you miss something, just pause it, write it down. Okay. Number 2. Number 2 does not look as nice as number 1, but I'm going to say let x equal cosine theta. And then I'm going to do 2x squared plus 7x minus 4 equals 0. So I just replace the cosine thetas with x's. Now we're going to do the AC method, right? Because when the a value is not 1, we choose to do that. So we do 2 times negative 4 is negative 8. What two numbers multiply to give us negative 8, but add together to give us positive 7. Negative 1 and positive 8 will do that. So then I replace the middle with, so I have 2x squared minus x plus 8x minus 4 is equal to 0, right? Negative x plus 8x is equal to 7x. That's why you're allowed to replace that with this. Split the middle and then take the GCF. So you have x times 2x minus 1. The middle sign always comes down, plus 4 times 2x minus 1 equals 0. Right, then you write down what is in parentheses and then what's not. So we have 2x minus 1 times x plus 4 is equal to 0. I'm going to solve each one of them for x. 2x minus 1 equals 0. 2x equals 1. X equals 1/2. X plus 4 equals 0. X equals negative 4. So now what we have is we have cosine theta is equal to 1/2 and cosine theta is equal to negative 4. Well, do you know that cosine can never be greater than 1 or less than negative 1? We're going to have to reject it. If I did use my calculator and I did second cosine of negative 4, inverse cosine of negative 4, what would happen is I would get an error. It wouldn't even work. Okay? But now cosine theta equals 1/2. Well, where is cosine 1/2? Second cosine of 1/2. Now, by the way, this is in our table that we're supposed to know. So anyway, the cosine of 60 is 1/2. Okay? So the reference angle is 60 degrees. Then we're going to go this way. Where is cosine positive? Cosine's positive in quadrants 1, where they're all positive, and quadrant 4, where cosine's positive. So what do? So quadrant 1, 60 is 60. And in quadrant 4, we do 360 minus 60 is 300 degrees. So the answer to this question is 60 degrees and 300 degrees. And that is number 2. So it's really just what we did before. So we, with the linear, but we have to do it twice now. First we have to factor it, and then we have to find the answers that go with both of them. Okay. I believe the videos are getting to be better quality as I get better at doing this. The Zoom was very interesting today. That also got better as the day went on. So we're going to be Zooming on Mondays and Wednesdays, okay? Number 3, sine squared theta minus 1 equals 0. Well, I'm going to let x equal sine theta. So then I have x squared minus 1 equals 0. Well, x squared minus 1 is a difference of 2 squares. Dots, right? X plus 1, x minus 1 equals 0. Set both of them equal to 0. X plus 1 equals 0. X equals negative 1. X minus 1 equals 0, x equals 1. So now I have sine theta equals negative 1, and sine theta equals positive 1. Now, I don't have to draw it again because I have it right up here. We just drew it, and you would always have this reference. I don't need it twice on the same page. So where is sine of theta equal to negative 1? Sine's the one on the right, right? At 270 degrees, it's negative 1. So here is 270 degrees. And where is sine of theta equal to positive 1? Sine is positive 1, at 90 degrees. So the answer to this question is just 90 and 270. Okay, 90 and 270. Okay, 10 minutes in, more than halfway, I believe. Number 4. Number 4 now is the first one that says they want us to do it in radian measure. So now we have to make sure we do it in radian measure at the end. We can just convert it. So let x equal cosecant. Let x equal cosecant of theta. I don't like to use x when it already says x, so I'm going to change it to let n equal cosecant of x. So then I have n squared minus n plus 3 equals 5. Minus 5 minus 5, n squared minus n minus 2 equals 0. I'm factoring it, so I get n and n. What two numbers multiply to give you negative 2, but add together to give you negative 1, negative 2, and positive 1. N minus 2 equals 0, n equals 2, n plus 1 equals 0, n equals negative 1. Well, n is cosecant of x. So cosecant of x equals 2, and cosecant of x equals negative 1. Well, we have reciprocal trig functions. The reciprocal of cosecant is sine. I'm gonna rewrite this up here on the right. Cosecant x equals 2, and cosecant x equals negative 1. I'm just moving it up here. So cosecant, the reciprocal of cosecant is sine. So if I take the reciprocal of cosecant, and that's sine of x, then the reciprocal of 2 is 1/2. If the reciprocal of cosecant is sine, the reciprocal of negative 1 is actually still negative 1, right? This is really 2 over 1. This is really negative 1 over 1, negative 1 over 1, or just negative 1, right? You don't really need to write negative 1 over 1, but it's just negative 1. So then we have to find the reference angle, the sine of what angle is 1/2, the sine of 30 is 1/2, that's in our table. The sine of 30 is 1/2. Where is sine positive? Sine is positive in the first quadrant and the second quadrant. So 1 in the first quadrant is 30 degrees. In the second quadrant, 180 minus 30 is 150 degrees. And where is sine equal to negative 1? That goes back to our unit circle that we had before. Sine is negative 1 over here at 270. So this one is just going to be 270 degrees. But this question wants everything from 0 to 2 pi, so we really are not done yet. We cannot do that. So we have to convert all these answers. 30 times pi over 180 is pi over 6. 150 times pi over 180 is 5 pi over 6. And 270 times pi over 180 is 3 pi over 2. So the answer to this question is pi over 6, 5 pi over 6, and 3 pi over 2. Okay. And we will do one more. This last one is not going to factor at all. I'm going to have to use a quadratic formula. Okay? X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Thought I should get some singing done on my video. Anyway, here we go. Let x equal sine of theta. So then we'll end up with x squared minus 4x plus 2 is equal to 0. It does not factor. We could do completing the square, but most of you prefer the quadratic formula, I believe. So I will write it x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. A is 1, b is negative 4, and c is 2. So x equals negative 4 plus or minus the square root of negative 4 squared minus 4 times 1 times 2 all over 2 times 1. 4 plus or minus the square root of 16 minus 8 is 8 over 2. Now, you of course would have to have calculators, right? Even if it was just your scientific calculators, so to get the decimals. But this becomes, when I separate it into two branches, 4 plus the square root of 8 over 2, and 4 minus the square root of 8 over 2. This becomes, in your calculator, 3.414. This becomes 0.5878. Okay? So, and then when you do that in your calculator, guys, if you're going to do 4 plus square root of 8 over 2, 4 plus square root of 8 over 2, 3.414, and, okay, and then we do the other one. Just make sure that you use the alpha y equals button for a fraction, or that you put the whole parentheses around the numerator, or you'll get the wrong answer. So now we have x equals, but x is sine. So now we have, I'm going to go up here, sine of theta equals 3.414, which we're going to reject because that does not work. You will get error. It can't be greater than 1 or less than negative 1. And then we have the sine of theta equals 0.5878. And when you do the reference angle there, you do the inverse sine of 0.5878, or the whole entire thing, and you get approximately 36 degrees. It says to the nearest degree in the question. So, where is sine positive? Sine is positive in quadrants 1 and 2. 1 and 2, right? So in quadrant 1, 36 degrees is 36 degrees. In quadrant 2, 180 minus 36 is 144 degrees. Okay, 144 degrees. So the answer to this question is 36 degrees and 144 degrees. So that was a bunch of examples, okay? Not bad, right? Not a bad start. Your homework is going to be numbers debating numbers 3, 6, and 11. Homework. Numbers 3, 6, and 11 from the exercises section. From the exercises section of this packet. So numbers 3, 6, and 11. And I believe I'm going to have you hand them in on the Google platform. Okay, so I'm going to try to put it up there, and then you'll turn it in that way, because the emails are not the greatest. So that's why I set everybody up on the Google platform, and hopefully that'll work out nicely. So anyway, that is the video. I hope you have a great day, and this will be due at midnight. Okay, so this is Tuesday's lesson. It's due Tuesday night at midnight. Take care of yourself, everyone. Have a good day. Be safe. Bye.